Hey guys, in this video we're going to be designing the ultimate weapon system for Unity. I didn't plan for this to be a step-by-step tutorial. This is actually a commercial game that I'm working on called Shotgun Therapy. And I'm going to show you the weapon system that I'm using in this. And it's in fact a weapon system that I've been designing and iterating over for many years. And I was hesitating for a long time about how to approach this. Should I make a tutorial series about this? So I said, hey, let's just talk about it. I'm going to give you an overview of the principle that I used to design this weapon system. Right now in my game, I have an assault rifle and I also have a shotgun. All of this is using prototype art and there's still a lot of jank. I'm still working on the AI of the enemies, and for the shotgun, you can see that the muzzle flash is displaying on top of the camera. I can aim, but the focus of this video is really the weapon system. So when I click on the left mouse button, I can shoot. In fact, I have a limited magazine. Now it's depleted. I have to press R, and here the weapon is reloading, and now it's reloaded. I can shoot again. Doing all of these things in one script is possible. However, you have to think about scalability if you want to implement different weapons in your game, including melee weapons as well. Then you need a system that will allow you to express different types of weapons. For example, we can have a rifle that shoots hit-scan bullets, and this is not exactly it because it shoots physical bullets. You can briefly see them going from the camera position forward. Okay, now let's talk about a bit of theory. First, let me grab my shotgun and shoot this one in the face or in the back. Boom. Okay, let's go. Let's talk about some theory. Let me read you this quote by Steve Jobs, the founder of Apple. You've got to start with the customer experience and work back toward technology, not the other way around. So let's apply this quote to our subject today. How should we design a weapon system? Let's look at the users of firearms in real life. What do they see and what do they experience? So unless the user really knows the inner workings of a gun, generally users view guns as black boxes. The only control that you have over this black box is usually the trigger. You also have the magazine, so you can change the magazine to refill the ammo. And you have a fire mode selector that allows you, for example, to choose between single fire, burst fire, and automatic fire. You also have iron sights and scopes, so you can zoom in and zoom out. And since video games emulate reality, this is also pretty much what your players experience, except they will experience these elements through a gamepad or mouse and keyboard, or some innovative user interaction techniques like you find in VR games. As game developers, we have the advantage of not being bound to the rules of the physical world. So we can use the same system, the same black box approach. We can use the same system to implement melee attacks, be it with swords or whatever. You can imagine that your sword has an invisible trigger. So when the player presses the attack button, your character will attack with the sword once, and we can also use the fire mode if you want an automatic firing mode. Then your character will attack every second, for example. And I'm going to digress again a little bit, but this is very important. As a game developer, you have to suspend your disbelief. You have to view all the elements in your game not as their real-world equivalent, but as tools that you give your player to achieve a certain condition, and usually it's victory. So for me, a sword is just a tool, like a firearm. There's not much difference between them. And as much as you can see like a car being a main tool in some games, a car can be just a prop in the background. Okay, with that out of the way, now I want you to believe that swords also have triggers, also have fire selectors. And let's go, let's do it. Okay, let's use this image of an AR-15 to design our code. Okay, let's design some classes with the idea that we're going to separate the responsibilities of the weapon. Instead of having a giant weapon class, what we can do is have multiple classes that take care of multiple stuff, and the weapon class itself will simply be using all of these classes together to create the behavior that we want. First, let's start with the barrel. So here we can model this as a shooter class, and it will have a single method, shoot. What this class will do is spawn a projectile every time we call shoot, and it doesn't care about the fire rate, it doesn't care about anything. Every time you call shoot, it will spawn a projectile. If you call shoot 1,000 times a second, then it will spawn 1,000 projectiles a second. Why not also show you the code in my game? This is the shooter class. As you can see, it's a simple class with a virtual void shoot, and probably I should have it as an abstract class. Then we can inherit from it and create a projectile shooter. So what this projectile shooter will do is it will have a prefab, which is usually a game object, and every time you call shoot, it will spawn that prefab at the muzzle of the gun. I made this little drawing to illustrate the projectile shooter. So it will create a game object, and that game object can move however it wants. It can have scripts in it to make it move like a grenade, or make it move like a high-speed bullet, or make it move in a linear way, like the plasma rifle from Doom and other games with slow-moving projectiles. Then we can also create a hit scan shooter that derives from shooter. And instead of spawning prefabs, what this shooter will do is it will perform a raycast or even a sphere cast from the position of the muzzle towards the world. This is a pretty straightforward shooter that you find in most FPS games. Then let's add a third kind of shooter, a melee shooter. This shooter will be used to implement melee attacks, and we can do melee attacks in various ways. We can have a trigger in front of the character. If they perform the attack and there is an enemy inside of that trigger, then the enemy will potentially get damaged. We can also detect collisions with the sword. For example, we will check 3 points on the sword. If these points touch an enemy during an attack, then we will potentially damage the enemy. So no matter how you do it, this will all depend on your melee shooter. And of course, you can expand these classes even more by having different types of melee shooters, different types of hit scan shooters and projectile shooters. So it's completely up to you how you want to extend this. But the basic principle is this. This shooter performs the attack without asking questions. With this shooter class, we can already create a basic weapon class. So our weapon class will have a reference to a shooter, and in pseudocode, it can look like this. Then we can implement shooting logic in an update method. Let's define a rate variable and a next shoot time variable. In the update method, if the shoot button is pressed and time has reached next shoot time, then we will call the shoot method on our shooter, then set next shoot time to time plus our rate. This will allow you to have a basic shooting mechanic in your weapon. However, this forces the weapon to be in automatic firing mode. Usually weapons have a fire mode selector, which usually has these 3 fire modes. You have a semi-automatic mode, a full automatic mode, and a burst fire mode. In semi-automatic mode, the weapon shoots 1 bullet, and the user has to release the trigger and press it again in order to shoot another bullet. In automatic mode, which is the one that we've just implemented, as long as the user is pressing the trigger, the weapon will keep firing at a constant rate. And for the burst fire mode, it works like the semi-automatic. However, multiple bullets can be shot in quick succession. To represent these firing modes, let's create a class. We can define the rate variable here, since all fire modes usually have a rate. And now let's look at the methods. So the fire mode will need to be notified whenever the trigger has been pulled or released. Back to our pseudocode, even the weapon class needs to know when the trigger has been pulled and released. So here having a simple boolean like shoot button pressed is not enough to give us that information. So depending on the input system that you're using, you should be able to tell when the attack button has been pressed and when it has been released. So we're doing it from a high level perspective here, but you can implement it however you want. Okay, so on fire mode, we need an on trigger pulled and an on trigger released method. Then we also need a can fire and on fire method. And in our weapon, we'll of course have a reference to a fire mode or multiple fire modes. So here we can have an array of fire modes or a list and a current fire mode index variable to indicate which fire mode we're currently using on the weapon. Okay, let's model the behavior of the trigger on our weapon. Let's create two methods on the weapon, pull trigger and release trigger. So these methods will model the actual trigger of the gun. And in these methods, for example, in pull trigger, we'll call on trigger pulled on the current fire mode, and we'll do the same in the release trigger method. And on the update method, we'll check if the fire mode can fire. So we'll call the can fire method. If this is true, then we will ask the shooter to fire. Then we will call on fire on our fire mode, just to give it the information that yes, we've actually fired the weapon right now. So let's go back to our pseudocode. Here, instead of the rate and the next shoot time, we will not do this here. Instead, let's have an array of fire modes and a current fire mode index. Our weapon class will have a pull trigger and release trigger methods. Let's add a property just so we can get the current fire mode more easily. So this will be the fire mode at current fire mode index. So this is just a shortcut. In the pull trigger method, we'll call on trigger pulled on our current fire mode, and we'll do the same in the release trigger method. And here in the update method, what we'll do is change this if statement. Let's replace it by current fire mode can fire. In this case, we'll call the shoot method on our shooter. And instead of doing this, we'll call on fired on the current fire mode. So you can call it on fire or on fired. It doesn't matter. It expresses the fact that we're telling our fire mode that we have indeed shot our shot and it needs to do something about it. Okay, I'm going to zoom out. So now our code is much more compact. We don't have the logic of automatic versus semi-automatic or burst fire here. Instead, this logic will be on the fire mode itself. So let's go back to our design. Here on the fire mode class, we can inherit from it and we can create 3 classes for each fire mode: semi-automatic, burst, and full automatic. Let's see the pseudocode of the semi-automatic class. We can have a flag has fired that will indicate whether we have already fired the gun. In on trigger pulled, we'll set has fired to false. Then when the weapon will ask if we can fire, so here needs to return a boolean. When the weapon asks if we can fire, we'll check if has fired is false. In this case, we'll return true, otherwise we'll return false. And in the fired event, we'll set has fired to true. That way, when we call can fire again, the method will return false. So we actually need to release the trigger and press it again in order to reset this flag to false. So this is a basic example of a semi-automatic firing mode. So here we can also use the rate. I forgot to use the rate. So here, if the player pulls and releases the trigger very fast, they can fire as fast as possible. And in some games, this is actually possible. You can allow the player to fire as fast as they can pull the trigger or press the shoot button. Let's say we've defined the rate and the next shoot time variables in the fire mode class. Here, to check whether we can fire or not, we not only need has fired to be false, we also need that time to be greater than next shoot time. And when we have fired, then we need to set next shoot time to time plus our shooting rate. So this was the semi-automatic firing mode. The automatic firing mode is even simpler. This is what we implemented earlier. As for the burst fire mode, I'll let you implement this one, but basically it's about having like an integer, burst shots left. When the trigger is pulled, we reset this variable to 3 or to the maximum amount of burst shots, and we'll change the condition on can fire and we'll include this variable. So the fire mode will no longer need the trigger to be pulled except for the first shot. So for the first shot, we need the trigger to be pulled. And then for the subsequent shots in the burst shots, since we're calling can fire in the update method on our weapon, then the firing mode will keep firing and decrease this variable until it reaches 0. Perhaps we can go more in depth into this behavior in another video. Like I said in the beginning, I just want to give an overview of the weapon system. Okay, so we've worked on the trigger, we've worked on the fire mode, we've worked on the projectile spawning. And perhaps here, if we want to implement different types of weapons, we can have in our projectile shooter a list of spawn points, which will be transforms, and a max scatter angle. Using these variables, we can create a shotgun, but we'll actually need another variable. Let's call it bullet count or projectile count. So for each spawn point, we'll instantiate this number of bullets with this max scatter angle. So for the shotgun, if we have 1 spawn points, so this is our transform, then this is the max scatter angle. And here we'll have achieved a shotgun behavior. So the array of spawn points is perhaps more useful for spaceships. You can also use this system for spaceships or aircrafts. Let's say, for example, you have this spaceship and it has 2 machine guns. So if you want to represent these machine guns as one weapon, then you would create a spawn point here and another one here. And when the spaceship shoots, then it will shoot bullets from both of these points. Yeah, when I was making shoot them ups and like twin stick shooters, having a list of spawn points was useful, but in an FPS game, it's not as useful. So you'll have to decide whether you want an array. An array is certainly the most flexible solution. So if you have an array, you can also define like one single spawn point or many. But if you have only one spawn point, then your system will be limited to that. Okay, we've covered a lot of ground. Now let's talk about this little thing, the magazine. So with our system right now, the weapon will shoot an infinite number of bullets. What if we want to limit the number of bullets that the weapon can shoot? We need to model the functionality of this magazine. Let's create a weapon loader class. So on our weapon, we'll have a func here. Let's make this a bit bigger. Okay, let's add an isLoaded func, which will return bool, and will be set to a lambda expression that returns true by default. So by default, the weapon will always be loaded. However, if you add the weapon loader script to your weapon object, then this script will override the isLoaded func. So here, a basic example of a weapon loader is just a weapon loader with an int variable ammo set to, like, for example, 100. Then when overriding the isLoaded func, the weapon loader will ask whether this ammo variable is greater than 0. In this case, it will return true, otherwise false. And this is enough to limit the number of ammo that you can use. But we'll actually, like we did for the fire mode, we'll actually need to be notified. So the weapon loader will need to be notified whenever the weapon has shot one shot. So let's add an onShot method. And on our weapon, so here you can decide whether you want the weapon to have visibility over the weapon loader, which is not usually a good option. So instead, what we can do is define like a Unity action or a Unity event on the weapon that will fire whenever the weapon has shot. And what we can do, the weapon loader can subscribe to that event. Then whenever it happens, it will call the onShot method and subtract 1 from ammo. So the first time it will subtract 1, ammo will be equal to 99 and so on until it reaches 0. So this is a basic weapon loader. And the reason why I called it weapon loader and not weapon reloader is just an analogy with tanks. In a tank, you have a crew member who's in charge of loading the ordnance into the cannon or the gun of the tank, whatever it's called. So I like this analogy because I like to think of weapons as little tanks with little crew members, and these crew members are my scripts, and they're working together to load the ammo, to do all sorts of things. So here a slightly more advanced version of the weapon loader is a weapon loader connected to an inventory system. So here, instead of having ammo on our weapon loader, so we'll get like an identifier of the kind of ammo that we need, and the weapon loader will ask the inventory system, do you have enough of this ammo? For example, let's say we want 7mm rounds. In the inventory system, we have 5 left of those. So the weapon loader will ask, do you have enough? Do you have at least 1? And the inventory system will say, yes, we actually do. We have 5. And the weapon loader will say, okay, I'm going to use 1 now. So the inventory system will subtract 1 from here and it will become 4. and so on. So here you will notice that on our system, each class is responsible for a separate function, and even the visibility over other systems like an inventory system is very limited. It's in fact limited to the weapon loader alone. So in case you want to choose an inventory system or switch from one system to another, the changes that you will do will be very localized. So you'll only need to go into the weapon loader and change the code rather than rewriting your whole weapon system to accommodate this new inventory system. And that's actually a sign of a very robust and mature system. And the weapon loader can also take care of reloading, and magazine management is also a topic on its own. For example, you have these more realistic tactical shooters who give you a limited number of magazines that you have to manage. Then you have the more arcade shooters in which you have just a number of bullets, and when you're reloading, you're loading a magazine that's full of these bullets, which is of course not realistic, but for games like Half-Life, like Halo, the fun in these games is actually the story, the enemies and the environments, not actually managing your magazines. So it makes more sense to have this more arcadey approach. Okay, let's take a look at my own code. So this is the code of my game Shotgun Therapy. So here I have the weapon loader, and as you can see here, I'm using a finite state machine where I defined two states. We have the ready state and the reloading state. We're starting at the ready state, and here I have the number of rounds. So this is a temporary solution until I integrate an inventory system. So we have the reload duration, the reference to the weapon, and a timer. And we have events like reload started and reload finished. I'm using these events to play sound effects. So here I have a method to change the state. When we're going to the ready state, we're resetting the rounds to 30 and we're calling reload finished on the weapon and invoking reload finished. And here I have a method to update the FSM. So when we are in reloading, we will decrease a timer. When this timer reaches 0, then we'll switch to the ready state. So this is pretty easy to understand. And what's more important is that it's also easy to expand on. If you want a more complex component in your system, then you can totally improve it without affecting the other components of the weapon system. Okay, so that's it. We have a isWeaponLoaded, which I use here. So I use this to override the func on my weapon. So this is the func that we talked about. Let's control click on it. So this is my weapon class. And here I have the system func bool isLoaded, which is set to this lambda expression that always returns true. And this is what's great about this weapon system, is that the weapon loader is completely optional. If you don't have it on your weapon object, then the weapon will be considered as always loaded. Okay, I gave you an overview of my weapon system. I worked on this for years and I kept refining it and recreating it from scratch and always discovering faster ways to do things. But also, I'm not claiming that this system is like super complex and super sophisticated. This is the simplest system that I could come up with. I don't know if you noticed, but game development is a pretty complex subject. Game programming is very complex. So whenever you can simplify things and find the simplest solution possible, then oftentimes that solution will be better than something like more sophisticated that does like 1,000 things. But at the end of the day, if you can't understand it and if you can't like use it with a peace of mind, then that will cause you a lot of problems in the long run. So I always prefer simplicity in the systems that I create for my games. That way I stay on top of these systems. They may not be as sophisticated as something you find on the asset store, but at least it's my system and I understand how it works fully, and I designed it to be as simple as possible for my own needs. Alright, so I'll definitely make more videos on this. I'll probably make a series where we implement a weapon system. Until then, thank you for watching. I hope you learned something today. Leave me comments if you have any comments or questions about this. Thank you for watching. See you later.